So I put this together to help our various support engineers diagnose SIP connectivity issues between their CPE and our network proxies. Once you've got access to the trace tools within Arena, you'll quickly find the number of level 1 calls through to our support team are going to diminish. And if you're armed with this information, most of our job is interpreting the trace when you do come through to us. So some basic infrastructure. At its center is the network host or proxy. It's from the proxy that phones are registered and authorized. And as part of this process, agreement on the functionality capabilities of each phone is reached. So like that's conferencing, hold, presence, etc. The proxy aside, the two important concepts of SIP are the user agents and secondly the response codes. The user agents are the phones which can both initiate and receive calls. The response codes are a 3-digit code that defines the status of the request. Well, the codes are grouped into 6, defined by their first digit. The only 3 we need to concern ourselves with are the provisionals, the success, and the 400 client failures. Here's the process of the call itself. An inbound call from the SIPcity proxy to our customer on our network or a user agent. The invite initiates the SIP dialogue. The 100 is trying. 180 ringing is the first action. It's the phone ringing. And 200 OK is an answer and confirm with the acknowledgement. At this point, the media starts. Now, SIP doesn't come back into play until the call is ended, at which point we put through a buy once again to acknowledge. On our side, we've implemented the Homer SIP capture platform, which have also extended to partners through our Arena portal. A quick plug to the Homer team. We use their agents to pass SIP traffic from our proxy back to the Homer database. In Arena, we've provided our own UI, which governs access to Homer. And finally, under the federal government state of retention on terrorism legislation, we are forced to store captured data for 2 years from the time of the call. So here's our SIP capture tool, which we've called Trace. Your first views are the request response codes, which gives us a simple readable text-based format. With Trace, we've simplified what engineers would normally expect to have to wade through with tools like Wireshark. The first thing you'll notice are the calls are grouped by colors in descending order. Here's our invite. In this first example, we're looking at an inbound call. It's easy to identify as the agent in this case is the SIPcity PBX with our source IP of 103.55.116.65. The destination IPs is the customers, which is the 202.161. And in this case, you can spot the destination port. Jump into the packets if you need to dive a little deeper. The important detail here is the from and to. You can see where the user agent, once again, with the SIPcity PBX. The allow gives you the list of features, which in this case is the invite, acknowledge, cancel, subscribes, and the subscribed is presence. Another handy detail further down are the accepted codecs. You can view multiple packets, which we stagger for ease of reading. To registration, we've separated registration from the business of making calls. Remember that registration is the process of a phone connecting to our network simply to communicate its phone number. Its phone number's public IP, I should say, and the various LAN address details. In this example, you can see the initial register from the customer's IP, and then our 401 rejection, and finally the 200 OK. So now that's the phone registered. Anything else here is bad. For example, a 403 would indicate that the phone's attempting to register onto the network with the incorrect password details. To recap, for reading trace, we list in descending order, meaning oldest first. By default, we present the last 45 minutes of calls, which you can expand out to 24 hours if required. Similar for registrations, we limit to the last 10 minutes of registrations, but you can also expand that out to 24 hours. One point of note is that trace currently doesn't show the TLS encrypted SIP packets, but you can easily identify if TLS is the transport mode by selecting the green registration button, which actually tests the registration status against the console directly. The report turns the registration server, a millisecond response time, and helpfully, obviously, the transport mode, UDP or TLS. So this is subtly different from the registration status in the numbers setting, which simply reports the last time the phone was registered, which in a lot of cases could be the 3600 second or 1 hour manufacturer's default. As you get into problem debugging, you will find this console test a very useful tool. Finally, to cover peering, remember that registration is the process where the agent presents its username and password credentials and is authorized by our proxies to join the network. For peering, there's no registration as such. Customers link their static IP WAN address to their account, and we route calls to that address. There's a few security issues, firewall issues that we advise, but peering is the more scalable approach that's generally preferred by customers holding their own on-premise IP-enabled PBXs. I hope this helps. As you get used to trace and the console test, you will reduce your reliance on us to resolve level 1 issues. At the end of the day, these are the exact same tools we use as our first pass as well. If you come through to our support team armed with the capture and the console test results, in all probability our assistance is just helping you interpret the findings. Customers will be happy as your close times will fall substantially. That's trace and the console test. Don't hesitate to call if you need assistance with interpretation, and good luck.